And welcome to our second tutorial. In this tutorial, we will add and subtract rational expressions. So let's first explore the steps to simplify. Step number one, we need to find the LCD. The common denominators, they must be common so that we can add or subtract. Now, in order to do this, we might need to factor our denominators first because we'd like to see all of the factors. Once we have found the LCD, step number two, we're going to multiply the missing factors to the numerator and the denominator of the appropriate fractions so that all of the denominators are the same. Once we've done that, they should have the same denominators, and step three simply says add or subtract, depending on our operation, the numerators over that same common denominator. Usually we're finished at this point once we've gathered our like terms. Sometimes we're able to factor the numerator again, so I put a question mark, sometimes that's able to happen, and we could simplify more if we had a common factor. Usually we're finished after step three. So let's look at a few examples. Example number 4 in your notes is right here. We're looking to subtract these two fractions, and unfortunately I'm not able to do that right now because obviously their denominators are not the same. So I need to find the LCD. To find the LCD, I need to see all of the common factors in the denominator. And I don't see any factors yet. So that's what I need to do first. I'm going to factor this first denominator, x squared plus 4x plus 4. I know that x times x is going to be the front. I know that it could be 1 times 4, but I'm pretty sure the 2 and the 2 are going to help me to make the middle 4. So I'm going to guess 2 and 2. And I know that they both have to be the same sign, so they're both going to be pluses. I'm pretty confident that that's how we factor it. I'm just going to kind of scribble through this, and here's our new denominator in factored form. The second denominator is x squared minus 4. I remember that. That's the difference of two perfect squares. That's going to be x plus 2 and x minus 2. So I can factor that, and I'm just going to scribble through that and have the factored form of that. So I'm looking for my LCD. My LCD is the product of all of the prime factors. So I'm looking at the first one. This denominator has an x plus 2 factor. This denominator also has an x plus 2. Okay, so that's got to be part of the LCD. This one has another x plus 2. This one does not. So the denominators do need to have two x plus 2's. This one has an x minus 2 factor, and this one does not. So there is going to be an x minus 2 in there. And I think that we're good. So what we need to do is take each of these fractions and decide which factors are missing and make sure that we include them. So this has an x plus 2 and another x plus 2, but it's missing the x minus 2. So I'm going to multiply this fraction to the numerator and the denominator and x minus 2 so that it has that missing factor. Now if I'm going to put an x minus 2 next to this numerator of x plus 1, I should probably put that in parentheses now so that I can see that I'm going to be foiling up here. So there's the denominator, the LCD there. What is this one missing? Well, it's got an x plus 2 and an x minus 2, but it's missing the second x plus 2. So I'm just going to give it to it. I'm going to put the x plus 2 there. I have to do it to the numerator and the denominator. So I'm going to multiply the numerator and the denominator by x plus 2. And now I've got both fractions will have this common denominator. I'm going to go ahead and put that common denominator, which is x plus 2, another x plus 2, and an x minus 2. And I'm going to put that as both of these denominators because now I know that they will have the same denominator. Now let's do some math. We've got some foiling to do up here, first, outer, inner, last, and that will result in x squared minus x minus 2. If you need to go off to the side and do that work, that's fine. The second fraction, I'm distributing a 2 here and here. So 2 times x, of course, is 2x, and 2 times 2, of course, is 4. Now I have two fractions that can subtract because they have the same denominators. So they're going to combine to become one fraction. The denominator of of this fraction is going to be the same. And now let's see what the numerators become. X squared minus x minus 2 minus, now watch out for subtraction. Not only are we subtracting the 2x, but we're also subtracting the 4. It's like distributing again, negative 2x and negative 4. So now we have one fraction, and we just have to clean up some like terms in the numerator. I see that there's a negative x with a negative 2x, and I also see that there's a negative 2 with a negative 4. I can combine those together to make x squared minus 3x minus 6 divided by the same denominator. But you know what I'm going to do? Since these two factors are identical, I'm just going to write it as x plus 2 quantity squared. That might be a fancier way of doing that. And there's our final answer. You might think that you could try to subtract this numerator, but there are no factors of 6 that are going to combine to give a 3. So I know that that's not going to factor. So here's our first example. The second example, you don't actually see two fractions yet. So I'm going to put the first one over 1, as everything can be, and now I can see that there are two fractions. I can also now see that the denominators, of course, are not the same. So I do need to find the LCD. This LCD is not too bad because there's only one factor in this denominator. It's y minus 1. So y minus 1 must be the LCD. Since that's the factor that's missing in this first fraction, I'm just going to multiply y minus 1 to the numerator and the denominator. Now I'll have two fractions, each with a denominator of y minus 1. The second fraction actually didn't even change. So I'll put that numerator there. The first fraction, I'm going to distribute this y here and here. Y times y is y squared, and y times negative 1 is negative y. Now that I see that I have the same denominators, I can combine these two fractions into one just by adding the numerators. I know I'm adding. Y squared minus y plus 3, and that's actually going to be where we stop. Again, you could try to factor this, but it doesn't. So we're finished with those. Let's look at one last example in this tutorial, and here it is. We're trying to add two more fractions. I know I'm adding because there's a plus sign in between them. Unfortunately, their denominators are not the same. So let's practice factoring these denominators so that we can see all of the factors that we're going to need for our LCD. This denominator simply has a GCF, just a little 2. I'm going to pull a 2 out, and I'll be left with x minus 5. That's just a GCF, and I'll kind of scratch this one out. This is my new denominator, at least the factored form of it. This is a trinomial. That's going to be a trial and error. I know that it's going to be x times x, so I'll do that. 1 times 15, also 3 times 5. That gives me 15. And I know 3 and 5 are going to help me with the 2, so I'm going to guess the 3 and the 5 first. The minus sign here says that the signs have to be alternating in my factors, so the bigger one needs to be negative to remain, for the middle term to be negative. So negative 5 and positive 3, that should do it. You can double check that mentally. So now I see all of my factors. My LCD is the product of all of the prime factors. So the first thing I notice is that there has to be a factor of 2. So I'm going to put that in the LCD. I see that there's an x minus 5. This one actually already has the x minus 5 as well, but it does need to be there. So I'll put the x minus 5. And, well, that's it from this denominator, but there is one more factor that I see, and it's the x plus 3. So x plus 3 is going to also need to be in the LCD. So both of these fractions are going to become new fractions with that LCD, the 2, the x minus 5, and the x plus 3. The 2, the x minus 5, and the x plus 3. Once both of these fractions have this denominator, then I'm able to add them. So let's see what's missing. This one has the 2 and the x minus 5, but it's missing the x plus 3. So I'm going to give the x plus 3 to this denominator, but I also have to do it to the numerator. And therefore, I'm going to put parentheses around its numerator so that I can see the FOIL again. This one has the x plus 3. It has the x minus 5. So it has those two, but it's missing this 2. So I got to multiply by 2 to the numerator and to the denominator. So we found the missing parts. We put where they need to be. Now I'm going to FOIL this numerator. I've got x times 3x is 3x squared. My outer terms are 1x. My inner terms are 9x. I can do that in my head to make 10x. Again, if you need to go off to the side or show another step, please do so. And last terms, 3 times 1 is 3. So I FOILed that. The numerator up here is just 1 times 2. Done. Now they have the same denominators. I know that I can combine these two fractions together. And the denominator will stay the same. Simply by adding the stuff in the numerators. This 3x squared plus 10x plus 3 plus 2. So really, I'm just going to do this in one step. I see it's just 3 plus 2 that makes the 5. So I've got my 3x squared, my 10x, and my 5. So this tutorial is all about factoring the denominators, finding the LCD, making sure that the missing pieces get to the numerator and denominator of the appropriate fractions, and then simply adding or subtracting the numerator depending on what operation we have there. Looking at our next example, example 7, let's look at these denominators. Oh, they're different again. These are not the same denominators, so therefore we cannot add these fractions yet. What we need to do is find the LCD. Let's factor this denominator. This is another GCF problem. I'll pull out the 4, and I'll be left with w minus 4. Bye-bye. And this 8 minus 2w, I can factor out a 2 as a GCF, and I'm left with 4 minus w. Bye-bye. Now let's look at these denominators because something happens here that was on a previous tutorial in the multiplying and dividing. Obviously there's a 4 here and there's a 2 here and it needs to become a 4. But the w minus 4 and the 4 minus w, they are not the same factors, but they're so close. Remember in a previous tutorial, we can flip around a minus sign and change this to w minus 4 as long as we understand that how to do that is factoring out a negative, meaning that there has to be a negative multiplied into this fraction for us to be able to do that. And that's what I'm going to do because then they will be identical factors. So I can flip around a minus sign as long as I remember that there's a negative that has to be multiplied to this fraction. And then I'll scratch that one out. Okay, so my LCD is the 4 and the w minus 4. Those are the factors that are needed. This one clearly already has both of them. This one has the w minus 4, but it only has a 2, meaning that I need to multiply one more time by a 2. And in this case, in the numerator, I'm going to multiply by a negative and a 2 together. Okay, so let's see. This fraction here, which has the same denominator, and this fraction will become 2 times 2 times w minus 4. It will become the same denominator. This does not change since this fraction has not changed yet. This one up top, I should probably put this in parentheses so I can distribute a negative 2 here and a negative 2 here to make negative 2w minus 8. Now I can add these two fractions together simply by combining like terms from the numerator. The denominator does not change. The numerator, I've got a 3w plus a negative 2w. That's like 3 minus 2 becomes 1, so 1w. 16 plus negative 8 is positive 8. Now we're finished. Thanks for watching this tutorial, and we'll practice this more in class. I'll see you then. Oh, thank you. See ya.